Alright, now we get a chance to analyze the function and the derivative function to see if we can establish any concrete relationship between the two. Alright, between the two. I'd like you to take a look at the original function, which is right here. Okay, and that's graphed, and I'm going to trace the graph of the original function for you. And then here is the derivative function. So at any point I can figure out what the derivative is, what the slope of the tangent line is. For example, if you look carefully, this is the point -1. Okay, so at -1 you can clearly see that the slope is equal to 0 because the slope is a horizontal line. If you did not have this graph, we can also figure out that the slope equals to 0 if we plug -1 in for x. See? So this function is pretty cool because it allows us to know the value of the slope of the tangent line quickly. Alright. Now, one thing I want you to kind of be aware of is the function is decreasing. The highlighted function is decreasing from -infinity up to -1. So it is decreasing from -infinity up to -1. Okay, and you can see that right here. This is the part where the function is decreasing. Now, when the function is decreasing, if you look carefully at the slope of the tangent line, the slope of the tangent line is negative. If you look carefully at this line has a negative slope. So we can conclude that when the function is actually decreasing, the derivative function will have a negative value for any x value where f is decreasing. Graphically, you can look at it. You can look at the part where the function is decreasing and notice that any tangent line on this part will have a negative slope. Analytically, the function is decreasing from -infinity up to -1. So if you plug any x value into the derivative function, it will also give you a negative slope. Alright, so hopefully that is clear for you. I try to go really slow because I know that can be confusing. But take your time, okay? These are not easy concepts. On the other hand, when the function is increasing, sorry about that, that just says increasing. When your function is increasing, and it is increasing from -1 all the way to infinity. You see how the function is climbing, right? So I know that it is increasing from -1 to infinity, right? The function is increasing. I guess technically it's increasing after -1, so that's why we're going to use parentheses, and it's decreasing just before it gets to -1. Okay, but don't worry. On the AP exam, they don't care whether or not you use brackets or parentheses, so don't worry. When the function is increasing, I want you to notice that the derivative or the slope of the tangent line is always gonna be a positive number. If you calculate the slope of this line, it will be a positive number. So, and another way to even look at it is if you take any numbers in this range and plug them into the derivative function, you're gonna get a positive slope. Because remember, this function spits out the slope, right? So therefore, we can conclude that when the function is actually increasing, guys, the derivative will yield a positive number. All right. this is cool because by knowing these characteristics, we are able to get a feel for the value of our derivative without doing a lot of work. We can actually take a look at the curve and say, oh, for sure that the derivative from negative infinity up to 1 is going to be a negative number. And the derivative from negative 1 to infinity is going to be a positive number because the graph is actually increasing there. All right. This allows us to sketch the graph of the derivative. Isn't that cool? We can actually sketch the graph of the derivative. So before we start, I developed this rule number 1 for you to kind of follow on how to sketch the graph of the derivative. All right. And I hate to say it, but remember that these are challenging topics and you will need to persevere through these in order to understand it well. And the good news is once you understand it, you'll understand it for life. All right? But it will take some time, so have some patience. I know that it takes work to get to where we want to get to. All right? So keep that in mind. So can we sketch its derivative? And the answer is we can, because we know how the derivative, we know the derivative value depending on whether or not the graph is increasing or decreasing, right? So we know that when the graph of the original function is increasing, then the derivative is positive. And another way to think of that is it's always going to be above the x-axis, right? Because when something's positive, it's always going to be above the x-axis. It's going to take on a positive value, therefore it's going to be above the x-axis, right? If the function is decreasing, then the derivative value is negatives. What does that also mean? Graphically, this is going to be below the x-axis, right? Because if you think about it, any negative number is really below the x-axis, right? Any positive number is above the x-axis. Okay, keep that in mind, and if you can, you're going to be all right. And then, if the function is a flat point, then the derivative must be 0. That means the derivative is touching the x-axis, because that's what it means to be 0, right? That means you're touching the x-axis. All right, so cool. Let's go ahead and sketch our first derivative. The way how we sketch our first derivative is we start out by identify where the graph is increasing and decreasing. So I'm going to use the color blue to represent decreasing. Okay, decreasing. So check this out, guys. This is where the graph is decreasing. All right, that's where the graph is decreasing. This is also where the graph is decreasing. Okay. All right. Good. So we kind of identify that. I'm going to use the color. I'm going to darken the graph in black for increasing. Okay. So like this. Okay. And then right here. Okay. And I'm going to use the color red for when the graph is flat. It's flat. Flat means, or another way to say flat is when it turns, when the graph turns, right? So the graph is going to turn right here, okay? And the graph is going to turn right there, and the graph is going to turn right there, okay? So we start off with where the graph turns. Okay, so the graph turns at these 3 points. So guess what? The derivative must be 0, and that means that the derivative will be touching the x-axis. And I'm going to want to use a different color to do the derivative. If you don't mind, I will use this color. Okay, it's also black, but hopefully it stands out a little bit. And then I'll highlight it in my highlighter. So here's what I'm going to do. The derivative, wherever it turns, the derivative equals to 0. So I put my dot on the x-axis. See? So where f is flat, these are flat, the derivative equals to 0. Would you agree? If you think about it, just draw the derivative. Isn't that 0? Isn't that a slope of 0? Okay, that's a slope of 0. That's a slope of 0. So how do you graph 0? Well, if it's 0, then it's touching the x-axis. That's what it means to have a height of 0, right? Good. Now, let's go ahead and focus on where the graph is decreasing, okay? Where the graph is decreasing. Remember, decreasing means that the derivative is negative, and what it means by the slope being negative is that the graph will be below the x-axis, right? The graph of the derivative will be below the x-axis. So check this out, okay? So at this point, remember, it's going to be a negative, so it's going to be, if we compare these negative numbers, these slopes, the slope is, it's really steep here, so it's going to be a really big negative, but then eventually it kind of slow down and then it kind of flat out. So here's what I'm going to do. I'm going to start here to represent a big negative number, and then it's going to flat out like that. Okay, see? So that's the slope. The slope, it's a really big negative, and all of a sudden eventually it kind of slows down, and then eventually the slope equals to 0. Okay, kind of hard to understand, huh? But keep in mind that slope is a number, right? And the slope here is really big in terms of negative wise. So if you look at a really big negative, that means that it has to be way below the x-axis. But eventually the graph can kind of level out until it reaches a slope of 0. So as you can see, it becomes big negative, but eventually it equals to 0. Okay, awesome. Now from here, for this region right here, the graph is actually increasing, and if the graph is increasing, then all the slope are gonna be positive. All the slope are gonna be positive. So the slope starts to get like a half, 1/2, 1, 2, 3, 4, 5. And then it actually gets smaller, like 5, 4, 3, 2, 1, 0. So in this region right here, the derivative is all positive, okay? And it's gonna look like this. It's gonna get really small, and then it's gonna get really big, and it max out there, and then it gets small again. But I want you to see that everything, the derivative from this point, from this domain to that domain, the derivative function is positive because the graph is actually increasing. Okay, from this region to that region, the graph is actually decreasing. That means that the derivative is negative. So it starts to decrease slow, and it decreases really fast, but then the decrease slows down until it flats out. So it's going to look something like this, guys. Okay. Notice that everything is below the x-axis because the slope is negative, right? Negative slope means below the x-axis. And then eventually this starts to increase really high, so it went like this. Okay. So all those slopes are positive. So guess what? This is the sketch of your derivative. Okay. You're done. Good job. That was a lot of work. Remember, this is not easy, okay? And if you need to, please watch this part again and go through and try to get this to kind of sink in. It might need a couple of runs before it does actually sink in, right? Watch the next part and then we'll finish the backside.